So yesterday I gave you a worksheet as homework, and I told you that the answers were online. I wanted you to check them. Okay, so last night, or I guess yesterday afternoon, I posted just the answers. Okay? What I'm going to do is this afternoon I will post all of the solutions so you can check this evening to see like if you couldn't figure out your mistake or you couldn't get to the right answer, what the work is to go along with it. Okay? And what I'm going to do, I'm going to go ahead and finish out the 8.5 notes. We're going to have some work time in class this afternoon. So if there was something that you had a question about from the yellow worksheet, you can ask me during that work time. Okay? We also can start on our 8.5 assignment and maybe save you some time this evening when you maybe have other things to do. Okay? So we're going to go ahead and start the 8.5 notes. I will remind you that on Tuesday we did talk about 3 things, right? We talked about the area of a triangle, collinear points, and writing the equation of a line, all with that matrix with the ones in that third column. Okay? You'll see those problems today in your homework, and then you'll also see what's called Cramer's rule. So we're going to talk about Cramer's rule right now. Okay, so Cramer's rule is our third way in this chapter to solve a system of equations. Okay? And what Cramer's rule does is it actually uses determinants to find it. Okay? Do you remember your determinants homework from Tuesday? How long did those take you? Like not very long, right? Okay, so Cramer's rule uses numerous determinants that we calculate, and we put things together in a certain way to find the coordinates. Okay? So if we have a so you may want to make a note to yourself that we're using this for a system of equations. Okay? So if we have a system of equations, we are going to let matrix D, well, D is going to stand for determinant, okay? But D is going to be the determinant of the coefficient matrix, okay? We are going to take the coefficients of x, y, maybe z, maybe w if we have a fourth variable, okay? We'll take the coefficient matrix and find its determinant. Then what we do for each variable, okay, we're going to find another determinant. So right now I'm going to talk about d sub x. What variable do you think this is going to help us find? X. We'll also find one, d sub y. That will help us find y, etc. But if I'm looking at d sub x, then we're going to take our coefficient matrix, but the x column we're going to replace with the constants. Okay, so just kind of preview down to that example down below. Do you see the 3x plus 4y equals 1 and the 5x plus 3y equals 9? If I'm talking about the constants, what numbers am I talking about in that? 1 and 9. Okay? So we're going to take a 2 by 2 matrix for that particular example. And if I'm finding d sub x, then the x column gets replaced with those numbers. Okay? If we find d sub y, the y column gets replaced with those numbers. If we're in 3 variables and we're finding d sub z, then we'll replace the z column with those numbers. Okay? So after we find our determinants, okay? Determinant D, if we have a 2-variable system, we'll find d sub x and d sub y. If we have a 3-variable system, we have to find d sub x, d sub y, and d sub z. Then to get our coordinates, we are going to take d sub x and divide it by d. We'll take d sub y and divide it by d. And then if we have three variables, d sub z, and divide it by determinant d. Okay? So we find our determinants, and then we create fractions out of them. Now, hopefully, okay, if we have integer solutions, these will divide nicely. But is it possible to have non-integer solutions? Yes. Which this would be a pretty nice method if we did have non-integer solutions. In row echelon form, some of you became very frustrated in an augmented matrix if you had fractions, right? It's just, it slows you down a little bit trying to do your row operations, okay? But this would be a method to where if we had fractions, it's not going to slow us down at all, okay? So let's look at this first example down here. This is your system of equations, okay? So we are going, since this is a two-variable system, we're going to have three determinants we need to find, okay? Always start with determinant D. And determinant D is the determinant where you take these coefficients right here, okay? So my first row is 3, 4, and my second row is 5, 3. You just take those coefficients, all right? And then when we calculate the determinant, how do we do that, Reagan? What do we do? Okay, so we have 9 minus 20. So negative 11 is determinant D. Now we need to find each of the variable determinants. Okay. So for D sub x, we're going to take the determinant of almost the same matrix, but since x is the determinant we're finding, we're going to take the x column and we're going to replace it with these numbers right here. So the x column is 1, 9, and we keep the other column the same. Do you see how we changed that? The x column changed because we're finding d sub x. All right, so Brecken, what would our determinant be? Okay, negative 33. We have 3 minus 36. So negative 33 is d sub x. Now, for d sub y, we're going to take a determinant, and we're going to use our our coefficient matrix, but this time the x column gets to stay as the 3, 5, but the y column is going to get replaced by those constants. Hayden, what's our determinant? 31?
Yeah, 36 minus 5. No, sorry, 27 minus 5 is 30. I don't know why I saw 36.
It's okay. We're still getting warmed up, right?
Yeah.
Okay. All right. So now that we have these three numbers, our xy coordinate, remember we need to take, for x, we need to take d sub x over d. So if we do that here, we would need to take negative 33 divided by negative 11. Okay. D sub x divided by d. Then for y, we're going to do the same thing, but with d sub y. D sub y is 22 divided by d is negative 11. So what is our coordinate? 3, negative 2. With zero algebra, we have the intersection of these two lines. Can we decorate this? Always for a system of equations, we know if we have the right answer or not. Okay? So our coordinate is 3, negative 2. 3 times 3 plus 4 times negative 2 is 1. 5 times 3 plus 3 times negative 2 is 9. All right, let's look at the 3 variable one. How many determinants are we going to need to find in order to solve a 3 variable system with Cramer's rule? 4. Okay. We'll need matrix, we need determinant D, and then we need D sub x, D sub y, and D sub z. So this is what I want you to do. Look at me right now. I do not want you to calculate any of the determinants. Right now, I want you to set up what the 4 determinants should be. Set up determinant D. Set up determinant D sub x, D sub y, and D sub z. Let's make sure we set them up correctly before I have you find them. So leave space to calculate them. So maybe like put them all vertically from each other. Okay. Set up the 4 determinants needed and label them so you know which one is which. When you have all 4 of them written down, check them with your neighbors, see if you agree with the setup of the 4. All right, Kelly, can you read me the rows, like go by rows, for matrix D?
Sure. 4, negative 1, 1. And then what the other side of it, or just that?
All 3 rows.
Okay. 2, 2, 3. And 5, negative 2, 6.
Okay, good. We just take all of our coefficients and throw them into a matrix for a determinant. Okay? For d sub x, Carly, can you read off your rows for that one? Okay, so notice how, notice how the x column, those numbers match up with these right. Oh, that didn't work the way. There we go. Notice how these match up with those numbers there, and all of the other numbers are the same as matrix D. Okay? All right? D sub y. Gracie, read me your rows.
4, 12, 2, 1, 3, 5, 22, 6.
Okay, so now the x and the z columns look the same, but if we look at the y column, okay, those numbers are replaced by those constants. Okay. Eli, d sub z, what would that matrix look like?
4, negative 1, 12. 2, 2, 1. 5, negative 2, 22.
Okay, so here, since it's d sub z, x and y, those two columns get to stay the same, but then we change the z column to be those constants. Okay, all right, so now we have 4 3x3 determinants to find. Okay, it might be a little bit tedious, but it's the same method over and over. Just to save time for us here together as a class, let's break up the work. Okay? If you sit in pods 1 or 2, please find the determinant of matrix D. And check each other to make sure we're all getting the same thing. If you sit in pod 3, then I'm going to have you find D sub x. Pods 4 and 5, D sub y. And then pod 6, D sub z. Okay, I'll have you, we'll just break up the work, we'll do some teamwork. Make sure you all agree on an answer before you give it to me.
For the first one, I'll just need to figure 48 plus negative 13 plus 4. I'm talking about the top. For the top of it? Oh, well, I gotta find D.
What'd you get for yours? I'm not sure. Don't erase everything. Just check them out. Bring your patience. you.
Turn up.
Part 5, were you by yourself? Or did you, who else had D sub y? Did you have D sub y?
Yeah, we got negative 165.
Alright. D sub y came out to be negative 165.
I got 42.
110.
Yes. Okay. Compare your work to Eli's and see what. D sub x is coming out to be 110.
Yeah.
What are you getting over here? Helpful? Out there. What are you getting over here? Okay. We're getting D to be 55. Some of you are working on other determinants, even though you had a classmate calculate it for you. I think that's great. 55. Woo! Okay. And D sub z is 55.
Wait, what did you get?
So your first step is right. You have 144 minus 66 minus 2. That's a good one.
Oh, I wrote down 72 instead of 76. Because I got 106.
There it is. Okay. So now, to find our XYZ coordinate, okay, we need to take D sub x over D and D sub y over D and D sub z over D, which would give us the coordinate 2, -3, 1. Okay. Now, I understand if you needed to use your calculator to do some basic multiplication on this problem because the numbers were a little bit bigger than normal. Okay, that's fine. Please do the determinants by hand for these 3x3. If I gave you a 4-variable system, then you can use your calculator, that's fine. Okay? But for a 2-variable and a 3-variable, for Kramer's rule, I need you to do it by hand. Now, if I were to give you a Kramer's rule on the test, the multiplication would be a little bit nicer, but it is okay to do some scratch work onto this side if you need to. If you have to multiply like 15 by a number or whatever. Okay, what we're going to do for the remaining 25 minutes of class, I want you to get started on your book work for 8.5. If you had some questions from your yellow sheet, now's the time to take care of that also. Tomorrow I will check both assignments, the yellow sheet and the 8.5 assignment. Okay, so let's make very good use of our time. If you have questions, ask me. But the entire time you need to be working on math of some sort. Okay, share books, take pictures of somebody's book and use your phone, whatever works for you.